In this video, you will learn how to identify trends in tables and graphs. All the equipment you need is a pen or a pencil. So we've got a results table here and we're being asked to describe the pattern. The first step to doing this is deciding if our dependent variable is increasing or decreasing. Our dependent variable is what has been measured. So if we look at our table, we can see we've got minutes of exercise, and then we also have heart rate in beats per minute. Our heart rate for beats per minute has got 1, 2, 3 measurements. And then we also have a mean which has been calculated from those repeats. So we can identify that this heart rate would be our dependent variable as it has been measured multiple times and then a mean generated from this. We then need to decide if our dependent variable is increasing. So let's have a look. At 0 minutes we have a mean of 64, at 10 minutes a mean of 80, at 20 minutes a mean of 106, then at 30 minutes a mean of 138. So as we can see, the numbers are getting bigger, meaning our dependent variable is increasing. We then need to write this out as a sentence, including the names of our independent and dependent variable, which we have already stated, the dependent being our heart rate and the independent being the minutes of exercise. So the answer would be, as the minutes of exercise increase, the heart rate is increasing. We now have a different results table and we're being asked again to describe the pattern, so I want you to pause the video and have a go. Well done for having a go at describing the pattern in the results table. We're now going to go through it together. So the first step, once again, is deciding if our dependent variable is increasing or decreasing. Once again, our dependent variable is what has been measured. So if we have a look, we've got distance of the plant from the lamp. We have the number of bubbles produced, and our number of bubbles produced has 1, 2, 3 values that have been measured and then a mean calculated from these. We now need to decide if this has increased. So let's have a look. At 10 centimeters, we have a mean of 103. At 20 centimeters, a mean of 75. At 30 centimeters, a mean of 57. And then at 40 centimeters, a mean of 34. So we can see that our numbers are getting smaller, meaning that our dependent variable decreases. It is decreasing. So, just the same as last time, we need to write this out as a sentence, including the name of the variables, which are the dependent being the number of bubbles produced, the independent being the distance of the plant from the lamp. So the answer would be, as the distance between the plant and the lamp increases, the number of bubbles produced decreases. So well done if you got that. Okay, we're now going to have a look at doing the same, but this time in a graph. The steps are very similar. So the first one would be identify what the variables are. In a graph, our independent variable goes along our x-axis, meaning that would be our current, and up our y-axis is our dependent variable, meaning our voltage is the dependent. We'll then need to decide what happens to this voltage, our dependent, as the current increases, being our independent. If we look at the points which are being plotted, we can see at each stage of current increasing, we are also increasing in voltage. Okay, we can also identify this by our line of best fit, going through the points, once again showing us that as current increases, so does voltage. Keywords to include when writing out the sentence to answer the question are increase or decrease. In this instance, we would use the word increase, so our answer would be, as the current increases, the voltage also increases. We now have a different graph. Once again, I want you to pause the video and have a go at answering the question. The keywords are there for you to use. Again, please include increase or decrease in your answer. Well done for having a go at describing the pattern. Now let's have a look at it together. So our keywords are there, increase and decrease. First, we need to identify what the variables are. We've already said our independent variable goes along our x-axis, that being the temperature, and our dependent variable goes up our y-axis, being the time taken to melt in seconds. So if we go to 20 degrees, we can see that we have a time taken to melt of 40, At a temperature of 40, we have a time taken to melt at 35, and at 60, we have a time taken to melt at 30 seconds. So we can see that as temperature is increasing, time taken to melt is decreasing. Once again, this is shown by our line of best fit cutting across the graph. So the answer would have been, as the temperature increases, the time taken to melt decreases. So well done if you got that.